So this is another review for our test about triangle concurrency area and composite area. Okay, so the first questions here are about vocabulary. Okay, these have attributes and they have definitions and they have what is the point of concurrency for each of these problems. Okay, so if you want to write these down or if you have the piece of paper with you, then pause the video and figure them out and then come back in 6 seconds to see the right answers. So there are your answers. Remember the difference between a point and a line. So the incenter is a point, the circumcenter is a point, the centroid is a point, and we're missing one, orthocenter. The orthocenter is your other point. Okay, and then your altitude, your angle bisector, your perpendicular bisector, and your median, those are all lines. Okay, so if it asks for a point, give a point, and if it asks for a line, say a line. Okay, number 9, find the area. So we have to identify, we have a top triangle with a base of 22. So our formula would be 1/2 of 22 times the height, right? And the height is this out here. So this is an obtuse triangle. So the height is outside of our triangle. And we have to calculate it by using our buddy Pythagoras. We have to use the Pythagorean theorem. So h squared plus 9 squared equals 15 squared. And of course we go to our calculator and we do 15 squared minus 9 squared. And the height is the square root of 144. Oh, I know that. That's actually 12. So the height of our triangle is 12. So you come over here with your 12, and then we do this into our calculator. 1/2 of 11 times 12. Sorry, 1/2 of 22 times 12 is 132. So the top triangle has an area of 132 square centimeters. And now we do a similar exercise to find the bottom. The bottom has a base of 22. And we have to calculate the height by using the Pythagorean theorem. So h squared plus 22 squared equals 40 squared. So in calculating this one, the height is the square root of 1,116. The square root of 1,116. So I plug that into my formula. 1/2 of the base times the height. 1/2 of 22 times the square root of 1116 gives me 367.472. Okay, and that's the area of the bottom triangle. Now, of course, since it's composite, I have to add them both together. And when I add them both together, I get a total composite area of 499.472 square centimeters. Okay, so we find the area of all the triangles that are available, and you add them up, and that is your composite area. Okay, there's a couple of questions on your test where you have to find the height by using the Pythagorean theorem. Okay, it's a very handy theorem that we use anytime we have right triangles. Okay, scooting over. Estimate the orthocenter of the triangle formed by these 3 points. So if I want to find the orthocenter, what lines must I graph? I have to graph their altitudes. Okay, so first of all, let's plot these points on your graph and make a triangle. Okay, so let's check here. If we're going to find the orthocenter, then we need to find the altitudes, and the altitudes require us to draw a line perpendicular to the opposite side. So let's look at point B. Let's look at point B. That means we need to draw the line perpendicular to side AC. And AC is a horizontal line. So what type of a line is perpendicular to a horizontal line? a vertical line. So we're going to draw from point B a vertical line that goes up until it intersects the opposite side. Okay, and that is perpendicular. The slopes are negative reciprocals, right? 0 and undefined. Undefined is your slope of a vertical line. Okay, let's do the same thing from point C. What is the slope of the side AB, which is across from point C? This has a slope of -1, right? Down 1, right 1, down 1, right 1, down 1, right 1, or down 9, right 9, which still reduces to -1. So my perpendicular slope to -1 is +1. So from point C, I'm going to make a +1 slope, which is down 1, left 1, down 1, left 1. Okay, and I make that until I intersect my opposite side there at AB. Now I know that's perpendicular because the slopes are negative reciprocals. Now of course I already see what this point of intersection is, right? So I can write down my answer. The orthocenter is at the point 2, 1. But let's finish this problem just to be secure and sure about this. So if I'm looking at point A, I need to find the slope of side BC. So if we do the rise over run, starting at point B, that's up 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units up and 2 units over. So side BC has a 9/2 slope. So what is the negative reciprocal of 9/2? -2 over 9. -2/9. So I'm going to start at point A and go down 2 and then write 9 units. 3, 4, 5, 6, 7, 8, 9. Okay, and I would do it again, only I know it's not going to be nice. So I'm going to stop when the line hits the opposite side. Okay, so when we're talking about altitudes, we need to find the slopes of the lines because we want to have it be a negative reciprocal, because negative reciprocal lines are perpendicular, and an altitude is perpendicular to the opposite side. Okay, let's get into some algebra. The base of a triangle is 7 times the height. If the area is 14, what is the base length? Base is 7 times the height. B equals 7h. So in my formula, area equals 1/2 of the base, and I'm going to replace base with 7h times the height, which is just h. Okay, so let's algebra this out. What is 7h times 1h? 7h squared. And what do I do with my 1/2? Times it by 2, right? To move the 1/2 to the other side, I multiply it by 2. So 7h squared equals 28. So now I divide by 7, divide by 7. 4 equals h squared, so I have a height of 2. The height of this triangle is 2. What is the base length? So if the height is 2, the base is 7 times, which is 14 centimeters. The height is 2, the base is 7 times 2. So look, the base is the same length as the area. Who knew? Kind of crazy. Okay, so if it says times, we solve by square rooting, or dividing and square rooting. This says the height of a triangle is 6 more than the base. More than. That's a plus. The height is 6 more than the base. B plus 6. The area is 260. Holy bejeebers. Okay, 260 equals 1/2 of base, which is B, times the height, which is B plus 6. So I am replacing the height in this problem because I have height equals. Okay, algebra. We're going to distribute our B into both of those, giving me a B squared plus 6B. And what happens to my 1/2? Times it by 2. We multiply the 2 by 1/2. 2 times 260 is 520. Okay, so now we need to make a quadratic by bringing the 520 onto the same side as your B things. So 0 equals, because we subtract 520 from both sides and get a 0 plus 6b minus 520. Okay, factoring. Right, when we're factoring this, I'm looking for numbers that multiply to give me 520 that are 6 units apart. What numbers multiply? So let's start with, I don't know, how about 24 and 30? Those are 6 digits apart. What's 24 times 30? Too much? Okay, 22 and 28, how about that?
It's still high.
Too high? Okay, let's come down to 20 and 26. Is that it?
Yeah.
Wonderful. 20 times 26. So mine factors to b plus 26, because the larger factor has to be the plus, and b minus 20. Okay, so b plus 26, because it's a positive 26, and I want a positive 6. So 26 minus 20 gives you positive 6. So when I solve each of these, my base is either negative 26 feet, or my base is positive 20 feet. And since this is geometry, we throw away the negative answer and keep the positive one. So my base is 20 feet. Okay. The area of an equilateral triangle with a side length of 6. Okay, this is the formula you need to memorize. Side squared, roots of 3 divided by 4. That is the area equation for an equilateral triangle. Okay, commit it to memory. When you come into class tomorrow, look at this, memorize it, memorize it, memorize it. Put it away while I pass out the test, and then write it down on your paper the moment that you get it. X squared, roots of 3 divided by 4. Okay, you should be getting 35.074, and our units are square feet. Side squared times the square root of 3 divided by 4. Okay, you have a question like that on your test tomorrow, similar, probably like number 8, somewhere between 5 and 8, you'll have an equilateral triangle. Okay, and then this one also, you have a question similar to this one. Now we know that the area of our triangle is 92, and it's asking for the side length. Right, so now we need to algebra this problem and solve it for x. Okay, solving this problem for x, your first step is to multiply everything by 4, right? Multiply by the denominator, and that eliminates your denominator from your problem. 92 times 4 is 368, equals x squared times the square root of 3. Okay, and now we divide both sides by root 3, right? We are multiplying here x squared times root 3, so we divide by root 3, and this will give us a decimal. The decimal is 212.465, my calculator says. And now I take the square root of that, and in square rooting both sides, I get 14.576 as the side length for my isosceles triangle, and my units are centimeters. Bless you. So you have a question on your test that wants you to find the side length of an equilateral triangle if you know the area. Right? So we're using that same formula, and we are algebraing it. We are doing the algebra to solve for x. Okay, number 21. The area of an isosceles right triangle. Ooh, isosceles right triangle. Not just an isosceles triangle, but an isosceles right triangle. Okay, that looks like this. That's an isosceles right triangle. Okay, it's also a special 45, 45, 90 triangle, if you remember that. So the base is down here, and your height is here. But what is true about the base and the height for an isosceles right triangle? They are the same thing. So because we need a variable, we're going to call them both x. So if the area is 80, we set up our formula. 80 equals 1/2 of base times height. 1/2 of x times x. Okay, this is only good for an isosceles right triangle. If it's a regular isosceles, this is not appropriate. Only for an isosceles right triangle. So what is x times x? That's x squared. And let's get rid of the 2 by, get rid of the 1/2 by multiplying by 2. So x squared equals 160. So square rooting 160 is a side length of 12.649. So that's one of the sides, right? And if I want the perimeter, I have to add up all 3 sides. So that's the side of 12.649 and another side of 12.649. But what about the hypotenuse?
Times root 2.
Multiply your side by root 2. And if you don't remember that, then you can always just use Pythagoras. Right? 12.649 squared plus 12.649 squared equals c squared. And when you take the square root, you should get 17.889. 17.889. Okay? So if it wants the perimeter, you have to find all 3 sides and add them together. So when I add these 3 sides together, 12.649, 12.649, and 17.889, I get 43.187 as the perimeter. So those are just regular old centimeters. So for an isosceles right triangle, the formula is 1/2 of x squared. Area equals 1/2 of x squared for an isosceles right triangle, because your 2 legs are the same for an isosceles right triangle. And then last question, find the area of this triangle. This is a normal isosceles triangle, so we have to draw in our height. And remember what happens with the height of an isosceles triangle.
It's a 30-60.
No, it's not a 30-60-90. It only bisects your base. Okay, on an equilateral triangle, the height does make 30-60-90s, but this is not an equilateral triangle, it's just an isosceles. So all that happens is we have a Pythagorean theorem that we can use to figure out what the height is. H squared plus 5 squared equals 30 squared. Okay, that's what we can do with our isosceles triangle. Okay, so in this case, the height is the square root of 375. No, 875, right? 30 squared is 900. 900 minus 25 is 875. So area equals 1/2 of our base, which is 10, right? 10 is the whole entire base. The whole base of our triangle is 10. Times the square root of 875. And my calculator says that is 147.902 centimeters squared. Okay, so the last thing to remember on each of these problems is to put your units. Okay, put your units for your problem. Okay, that's pretty good. Hopefully you feel more confident in solving these algebra questions as well as your vocabulary. Study hard, do great on your test.